Top of the day to everybody. It's good to be here. And thanks for the invite. I'd like to say top of the day to y'all, which is kind of an Irish Kentucky way of saying hello. So I'm going to talk about this idea of holistic, but it's just a little piece. It's not, the whole thing by any means. The disclosure is we have a mission to protect public health. So we're a nonprofit. 2/3 of our work is government, 1/3 industry. We do collaborative work. And I don't have any conflicts with this presentation. We're not working for anybody in this area currently, but if you're interested, give me a call or talk to me afterwards. So 3 bullet points. So we're going to, here's the abstract, and then we're going to give you the summary, which says the same thing. Hey, it's a balancing act, right? It's a balancing act between nutrients and unwanted chemicals. There's potential risks, ever present and very important. So you have to balance this stuff. We can eat too many potatoes, right? We can eat too much protein, and this is just the macronutrients. So what we're going to do is give you an algorithm to try to affect a balance. It's just a simple concept, actually. We're going to use it for fish consumption because fish is good for you, especially if you cook it, I suppose, but perhaps not. But it also has contaminants, some of them naturally occurring, like methylmercury. That's in every fish on the planet. And of course, some fish have a lot more. And we did this work for US EPA almost 20 years ago. We'll show that. So, you all know this. Cooking results in chemicals not desired. It reduces microbes, which we like. It's important to balance. And we're just going to get through the introduction because you've had some good talks about that already. So the first thing we're going to do is we're going to talk about severity. And there was an earlier presentation here today that talked about, well, we don't know what severity is. Well, I would push back a little bit. I think the toxicologists know severity pretty well. The medical people know severity. I mean, just think conceptually. You go into the doctor, you have a mild sunburn. The doctor says, okay, it's a mild sunburn. You'll recover. Your body will adapt. You don't have to worry about it. If you go a little bit further, you can get sun poisoning. Well, is that hospitalization? It depends. Is it all over your body? Then you're in the hospital. If it's just on a little patch in your body, well, we're just going to give you some Neosporin and spread it over there. You're going to itch. But in other words, there are levels of severity, and we're going to talk a little bit about that from an adversity effect point of view. But also, we're going to put the word severity for benefits, because we're going to try to balance these two things. And we're going to show you this by doing the fish thing. So the target risk is non-cancer and cancer effects from eating contaminated food. So we're going to talk in terms of fish. The loss of benefits when you avoid the fish, and we'll show you the loss of benefits. We have some really good data on that. And of course, there are benefits from certain foods when cooked, and we've already talked a little bit about that. I mean, one of the other things I do on the side is I write these science Bible stories. And one of the hypotheses is Homo erectus became Homo sapiens because of eating cooked fish in Ethiopia 150,000 years ago. And they've got some science about mitochondrial DNA mutation traced back. I don't know how these people do it, but there's some publications on there. So the first thing about this is, all right, let's talk about severity of effects. And you can get complex, but we're going to keep it simple. No observed effect level. It's a dose that causes nothing. A no observed adverse effect level. If you drink water, you could probably measure effects in your stomach, right? But they're not adverse. So it's a no observed adverse effect level. An adverse effect level, the lowest one, the frank effect level, if you look at the rat and it has yellow sclera in its eyes, the biopigments are backing up into the rat. This is a frank effect. We can see this. We don't have to cut the animal open to see the effect. And this happens at the clinical way too. So these are very clinical oriented kinds of severity of effects. And it's very simple. We're going to give these effects a multiplier. Now people say, well, wait a minute, frank effects aren't 3 times, greater than a no observed adverse effect level. And you're so correct. But mathematical people can do categorical regression. They don't need to have differences like that. They could just do categories. And they have a mathematics that are devoted to this. Now, in order to match, because we're going to balance, we're going to just give the same scale to the benefits. All right? Could you do different things? Sure you could. This is just one algorithm of probably many that could be done. So here's a severity of effects score for chlordane in cancer. Well, severity score 3. And if you take a certain type of fish that has a certain level of chlordane, and you presume that you're going to eat certain grams of fish per day, you can say 6.5 grams and an increased risk of cancer of 1 in 1,000. Upper bound, maximum risk, likely to be less, could even be 0. That's my EPA training coming out. When we say cancer risk, we always have to state it's an upper bound, it's likely to be less, the risk could even be 0. That's the full Monty, right? You'd never hear that in the newspaper reports, and sometimes my EPA colleagues don't repeat that, but you should. They should. Or if you're at 60 grams of fish per day, the risk is 1%. All right, if you're 120 grams of fish per day, which is a quarter pound, roughly, you're at 2% risk. This is with a severity 3. You can do the methylmercury, the non-cancer neurological abnormalities. You say, wow, a score of 1, a severity score of 1. That's not very severe. Well, you have to look at the methylmercury reference dose and the effects that we're seeing as a way of judging that. Somebody might score at 2. That would be fine. After all, this is something that we want to just do the balancing act. So arguments and discussions are always welcome. The non-cancer hepatic necrosis, it's 3. If you have hepatic necrosis, you're in the hospital in intensive care. Well, you can also do the severity of benefits. It turns out if you eat fish, there's a huge benefit. I eat 2 meals a week. Why? Because of this data. If you look over consumption rates and relative risk, if you eat 6.5 grams of fish, your relative risk of coronary heart disease is 0.6, 40% reduction. You eat 60 grams, it's 0.45. Well, 60 grams of fish per week is about, a couple meals a week. I eat 2 meals a week. All right? And stroke, the severity score of 3, there's a reduction not quite as great. Arthritis, severity score of 1. I have people that would disagree with me that that's a severity score of 1. Oh, well, okay, I'm listening. But you have also a reduction there. So now you can put these things together in a framework. It's not going to be complex. It's benefit plus risk, right? You're going to do some sort of index. In this case, it's a fish consumption index. The math is really simple. Why? Because I'm a toxicologist. I can't do complex things. Those little squiggle things that look like cobras? I know that means something, but I never can remember what it is. The sum of it is about as complex as I can get, right? So the benefits times 1 minus the relative risk is going to be, times your severity is going to be a benefit. Okay, you're going to get a score. It's going to be positive. I mean, if your relative risk is less than 1, it's going to be positive, right? And you're going to add these together. So you're going to take all the effects of this particular food, in this case fish, and cooking fish, and you're going to get a relative risk, a benefit here. You can do the same with risk. It's the risk, the increased health endpoint with a particular consumption rate, the severity endpoint you gave it equals a certain risk. And you can put the two together. Mathematically, this is my kind of math. So we should have just done one figure, sorry, but each figure has a scale that goes up to 1 on the y-axis. It's 1 or it's 0.5 or it's 0. And it has a corresponding negative on the y-axis, 0 or minus 0.5 or minus 1. And you can see with a fish that has a low concentration of carcinogen, that you have a benefits in the green. That's the top B on the upper left, sorry, for you. And you have a corresponding risk, which is on the bottom, the pink, real slight risk. As you eat more and more fish that has a very small concentration, you get an increase in risk. And the index is putting the two together. So a low concentration carcinogen in the fish, your conclusion is, my conclusion is, I'm eating the fish, because the benefit is huge. And a high concentration carcinogen is on the upper, what would be your upper left, no, right, sorry. And it's a little bit more of a risk. And then a low concentration non-carcinogen, that's your lower left. There's no decrease in benefit till you hit the threshold, which in this case is methylmercury. The threshold is 6 micrograms per liter of blood. And then a high concentration non-cancer, you lose benefit pretty quickly. So there are contaminated fish that you don't want to eat a lot of them. And so I had a colleague of mine from US EPA that says, I can tell you what the bottom line of your research with EPA is after 2 years and a team of people. He says, here's your conclusion: eat more smaller fish. And that's what we concluded after 2 years, is eat fish, but keep them on the small side. Lake Erie perch, primo, right? Catfish from the Ohio River that are 80 pounds, let's keep that one in the water, right? It'll be good for reproducing. So we gave you a case study, methylmercury in the Everglades. And, it's a result of point pollution, and it's methylmercury at concentrations, I think, in fish, 2 to 3 ppm. So this is a pretty high level of methylmercury. If you do fish consumption advisories, you'd like to see them in the 0.5 ppm range. And background is probably 0.01 or 0.1 ppm. So what we're going to do is, you got the health scale. Again, the y-axis it goes up to 0.8, 0.6, 0.4, 0.2, then 0, and then the minus 0.2, 0.4. And the x-axis is the fish consumption. So this is grams per day. So 120 grams per day, which is the last data point out there, is a quarter pound a day. Do some people eat that? Oh, absolutely. Some people eat, up to, almost a pound a day. That's a lot of fish, but, some people eat, 2 meals of fish a day. And you can see in this particular case that the threshold with that level is reached pretty quickly. So after about 5 grams of fish per day, you've now exceeded the methylmercury threshold, and you're getting risk. And that's at either the 50th percentile risk or it doesn't really matter which percentile you use, you're getting a risk because you're exceeding the threshold. And so you lose the benefit of eating that fish pretty quickly. So I think quite naturally, what the state of Florida did is they post a fish consumption advisory. You want to eat this fish? 5 grams a day. Well, that's hardly anything, right? So that's like 1 fish meal a month, and that's probably how they did the advisory, 1 fish meal a month, or a do not eat fish advisory. Okay, now there's some problems with this framework, and if you're a toxicologist, it's pretty quick. The benefits that we gave you are for the adults, right? Eat fish, you get less stroke, less cardiovascular disease, less arthritis. But the risks were to the fetus. I mean, the neurological effects that we showed you are fetal effects, and it's from the Seychelles Islands or the Faroe Islands or a mix of the two. I can't remember the original research. We probably used EPA's information, which was based principally on the Faroe Islands, and there's some issues with that, but that's okay. This is just demonstrating an algorithm. But that's an issue. If you're going to do this kind of algorithm, you need to match as best you can the benefits to the population that's suffering the risks. It doesn't really take into consideration duration, especially this case. I mean, the benefits to the adults accrued late in life, and the risks to children were early in life, and they suffer those benefits for their whole life. So how did you match, how did your severity scheme match? Good question. This is just an algorithm. All these things need to be discussed, especially if you get into specific occurrences. We only use one contaminant. So we aren't exposed to one contaminant. We're exposed to mixtures. So here's your coffee, right? H2O, dihydrogen monoxide. We went to Earth Day one day at Cincinnati, just upriver, right? And we had a little thing that said, should we ban this chemical? This goes back to Steve's thing yesterday about activism. Should we ban this chemical, dihydrogen monoxide? It is the principal component of acid rain. And we went right down and said all the things that dihydrogen monoxide does. You know, people die from it every year. It's unregulated by the federal government. I mean, we went down and everybody said, we should ban this chemical. And there was a yes and a no, and they said yes. It says, no, we shouldn't ban this chemical. And then they look at no, and it says, because it's water, right? Well, we didn't fake out 2 high school kids. They must have just had their chemistry class. They said, you can't fake us out. That's water. It's like, yes. 2 out of like 500. It was, oh boy. So coffee has 1,000 chemicals, right? And 20 to 30 of them are mutagens and carcinogens, including acrylamide. So here's a dose-response curve for acrylamide. This is fraction affected. So it's not percent, it's fraction. So 0.35 is the high thing on the y-axis, 35%. And the x-axis is dose of acrylamide in rats, milligram per kilogram per day. And you can see that there's a dose response, which is, this is 4 different studies pooled together. And you can argue if it's a linear curve or whatever. I mean, we were making the argument it's bimodal in this particular thing. You can see if you take a subset of the data, you can see the low dose response curve and all the various studies. Hey, acrylamide is causing thyroid cancers in rats. Now you can say, well, you know, rats aren't humans. They surely are not. And rats' thyroids are really pretty crummy compared to human thyroids. I mean, you can look at a rat and if you look at it wrong, its thyroid starts to quiver, right? But you can actually get rat thyroid tumors pretty easily. And humans are very resistant to thyroid tumors. But the point is, you can get a dose response curve here, and it's this information right here, or similar analyses of acrylamide, that have caused people to do Proposition 65 in California and lawsuits and people being concerned about, you know, reducing the acrylamide. It's this set of studies that was, you know, principal. Now the NTP has come out with some new studies. Okay, so on your right side is the same data I just showed you. That's the fraction of thyroid tumors in rats from acrylamide exposure, 4 studies, right? And whether you believe that's the proper dose response curve or not is beside the point. It's showing tumors. The other study is the percentage of mice with tumors from Stadler et al. 1990 that were given up to 5% of dried coffee in their diet. So we have mixture studies of coffee. And the rats got the fresh brewed coffee every day. That's all they drank. So I guess that was good to be a rat on that study, right? But the mice didn't get so lucky. They had to have it in the diet. And look, we have a statistically significantly decrease in cancer. Wait a minute. Those 2 graphs don't go together. So obviously, in the case of mice, eating the coffee was beneficial. Now, why was it beneficial? The authors have several hypotheses, but the authors said that each percentage in the diet is equivalent to 1 cup of coffee per day. So there's obvious a benefit in drinking the coffee. There's something in the coffee, maybe the mixture of the chemicals, that's a benefit. And what we would say is that there are algorithms that can be used to try to match the risks with the benefits. And that if you look at just one side of the story, what's reduced the risk, you may be doing something to the potato, or in this case, the coffee. You're taking the coffee out. You're reducing the acrylamide exposure. What else are you doing? Are you reducing the benefit? What else are you taking out? You see, you have to do this balance act. Okay, So it's an initial attempt. It's not supposed to be definitive. We can qualitatively evaluate the risks, but there's also attempts to do quantitative. You can do quantitative scaling as well. There's significant additional work needed. I mean, when we published this work with US EPA back in the early 2000s, you can see this work they've cited it. They're using for fish consumption advisories this idea of not so much weighing the benefits, but people understand the benefits. And again, eating more smaller fish is, highly recommended. We're going to need, doing risks for non-cancer effects because, reference dose is your safe dose. If you're above it, so what? But there are methods to do that. We need to talk about matching endpoints and magnitude of benefits. So severity matching scales, we have some citations there that seem reasonable, but a lot of extra thinking needs to go into that. And finally, we had on our group a couple different people. We had a Native American who basically said, you know what, I'm sorry, but eating fish is religiously important to us. So giving us a fish consumption advisory is a non-starter. And so you had to somehow bring in this cultural or social factor to the fish. Now, I just had my sister got back from Norway, and they have all this dried fish, and they have this lutefisk stuff, which is, whatever that is, and they just couldn't eat it, right? So, but that's a social thing. Over there, you're expected to partake. And so there's that aspect to the fish that you need to, or the food that you need to honor. So it's a balancing act. There's potential risks. They're present and ever important. And there are ways to go forward. And with that, I'll give you the credits, and I'll thank you for your attention. Questions for Mike?
Mike, thank you very much. Great talk.
Sure, thank you.
How do you propose to help us work this through an FDA regulatory scheme that has a regulatory standard that is a reasonable certainty of no harm, which doesn't allow for us to leverage the benefits that you talk about in that balancing act?
Okay. So FDA approaches that as seems reasonable on an individual chemical basis. But the mixtures guidelines of EPA, which our FDA colleagues are quite aware of, says the way to approach these things is mixture of concern first, a sufficiently similar mixture second, and finally, the addition of the various chemical constituents. So I think I would approach our FDA colleagues and say, hey, we've got, acrylamide in food, but we also have examples of coffee where, the mixture of concern is coffee, right? And drinking coffee is good for you. I mean, we can show lots of studies along those lines, and there's probably some other studies that are equivocal. But I would go into saying it's the mixture of concern, and we want to understand why that is, and approach it holistically, not individually. Because again, FDA is about good food. If you take out acrylamide, how did you get it out? Well, you extracted it with ethylene glycol or something else. What did you just do? Well, you changed, the matrix. So, but, our FDA colleagues are smart on this, so it's not as if you can't approach them. Other questions? Okay. Thank you very much.